Hello, welcome my dear beloved students. Very jubilant and happy to interact with you again in the electrochemistry part 3 videos. And I request all of you, before watching this video, two things are important. Take volume 1 chemistry textbook, volume 1, and take one more notebook, a legibly writing pen or pencil, not the pencil with broken head, and a keen interest and enthusiastic mind. Okay, because today we are going to do problems from the textbook. I already told you, ma'am. First, be thorough with textual problems. Later on, you go to so many problems, extra. At the end of this discussion, electrochemistry discussion, I may be tagging so many questions in the videos. Okay, so that is for practice. First, be thorough with textual problems, ma'am. So generally, in all the videos we had only discussions, etc. Today, for the first time, I am appearing in front of you with a textbook. Okay. So because I would like to indicate which problem I am going to solve today. So the problems are based on Faraday's first law, ECE, and allied laws of first law. Okay, right. Now, textbook back questions, exercise. Question number 3.15. I am going to begin with 3.15. So by this time, you should be ready with the textual exercise. Okay, I am ready. I hope you are all really ready. A solution of nickel nitrate NiNO3 twice is electrolyzed between platinum electrodes using a current of 5 ampere for 20 minutes. 5 ampere nickel nitrate NiNO3 twice nickel nitrate current 5 ampere. So I is equal to 5 ampere. Time. What is time? Time is 20 minutes. 20 minutes. The question is, what is the mass of nickel deposited at the cathode? Correct? So, what is the mass of nickel deposited at the cathode? Now, don't immediately go to the formula. M is equal to Z into I into T. Wait. Let us learn how to do this problem. See, actually, firstly, you can do this one. M is equal to Z into I into T. Sir, I given T, they have given in minutes. You convert this into seconds. So 20 into 60 seconds. So how much, ma? 0, 0, 12. 1200 seconds. This is the time. You have been asked to find out mass of the substance, mass of the nickel. M is equal to Z into I into T. I given, T given, but not Z. In this problem, electrochemical equivalent is not given. So, if we are not given with electrochemical equivalent, we have to bypass this formula. Okay, we have to use some other method by which this quantity need not be found out. What is that method? Now we are going to see what the method is. For your understanding, I am telling you molar mass or atomic mass of nickel. Atomic mass of nickel is 58.71. You can ask me, sir, how you know this? Practice, consistent reading, and very simple. At the end of the textbook, they have given. So all the three put together. Okay. So you can also verify if you have a log book. Refer to the atomic mass. Okay, right. Now we are going to solve the problem. How we are going to solve the problem? Nickel nitrate. Nickel 2 plus. Nickel 2 plus. Now let us see the reaction. What exactly the electrode reaction? Nickel nitrate is nothing but Ni2 plus 2NO3 minus. Na2 plus will be deposited at the cathode. So what is the reaction? Nickel 2 plus 2 electrons gives nickel. Before going to this equation, what I would like to know now, 5 ampere current is passed for 1200 seconds. So I would like to know the quantity of electricity passed through this solution. What is the quantity of electricity? Q is equal to I into T. I is equal to 5 ampere into T, 1200 seconds. Now, what 12 into 5, 60. Okay, 20. So 600. Okay. Ampere into second, got one coulomb. So how many coulombs are passed through the solution? 6,000 coulombs. Correct? Through this solution, this nickel nitrate solution, 6,000 coulomb of electricity is passed. Okay, right. So this is always when you are given current and when you are given time, be sure to find out quantity of electricity passed. CBSE always emphasizes stepwise marking, not final answer. Okay, so this is the quantity of electricity. Now, in the previous video, my dear beloved students, you might have learned that quantity of electricity required to deposit 1 mole. Actually, this is 1 mole of nickel. What is that? 2 Faraday, because valency is 2. 2 Faraday will deposit 1 mole of nickel. Or 2 into 96,500 coulombs will deposit 1 mole of nickel. How much? 58.71 gram. So 58.71 gram. Now you can know we are bypassing this. Is that? The answer is very clear. 2 into 96,500 coulombs of electricity deposits 58.71 gram of nickel. How much coulomb we are passing through the solution? 6,000 coulomb. Therefore, 6,000 coulomb will deposit how much? What is the answer? 6,000 into this divided by 2 into 96,500. So 6,000 coulomb into 58.71 gram divided by 2 into 96,500 coulomb. Coulomb gets cancelled. 0000. 2 how many times? 30 times. So what is the answer? 30 into 58.71 divided by 965. Okay, in board exam you have to use log. Okay, so 58.71 into 30 divided by 965. So the answer is very clear. 1.8251 gram of nickel is deposited. Okay, for all my beloved students, what is the advantage of writing electrode reactions? By using electrode reaction, we need not rely, we need not depend on Z. Okay, indirect way of doing this. So this is the method of doing this problem. Kindly watch it clearly. After watching this video, try on your own. Okay. Okay, ma. Next, problem 3.12 from your exercise. What is the question? The question is, how much a charge is required? How much a charge is required in a quantity of electricity? They didn't specify whether in coulomb or in Faraday. So I did both. For the following reduction, 1 mole of aluminium to aluminium 3 plus to aluminium. This is very important part of the discussion now. Here, how you are interpret 1 mole of aluminium 3 plus to aluminium, first division. 1 mole of Cu2 plus to Cu. 1 mole of MnO4 minus to Mn2 plus. Correct? You know how aluminium is reduced. Al3 plus 3 electron gives Al. Yesterday we studied quantity of electricity required to deposit 1 mole is N into F Faraday. Here the valency is 3. So 3 Faraday. And there N refers to valency, or I said number of electrons involved. Here also number of electrons involved 3. So 3 Faraday. Coulombs 3 into 96,500 coulomb. Upon multiplication you get 28,950 coulomb. Second division 1 mole of Cu2 plus 2 Cu. What is the electrode reaction? Cu2 plus 2 electrons, you get Cu. Correct? According to the formula, N Faraday, valency 2F. Number of electrons involved 2. So 2 into 96,500 coulomb. This is the answer. Okay. Third division. What is the third division? 1 mole of MnO4 minus 2 Mn2 plus. Here, this is simple ion. These are all simple ion, monatomic ion. This is polyatomic ion. We do not know how many electrons are transferred. This is monatomic. So Cu2 plus 2 electrons, Cu, we can do. Here this is also monoatomic, but this is polyatomic ion, MnO4 minus, where which ion is undergoing change in manganese. So here they said manganese 2 plus, but here what is the oxidation state of manganese? We do not know. Because it is polyatomic, here copper 2 plus, aluminum 3 plus. Because it is monatomic, manganese MnO4 minus is polyatomic. It is in combination with oxygen. So what is our utmost concern? Our utmost concern is we should find out the oxidation number or state of manganese. That is the hint I have given. Correct? As I said earlier, students with a little bit grasp, they can understand this. Others, sir, here you did directly. Why you are doing something indirectly and not indirect? I am telling you, this one and this one, these two are monatomic ion. If it is monatomic ion, change in number of electron easily predicted. Here, manganese is in combination with oxygen. So I should find out the oxidation number of manganese. MnO4 minus manganese X 1 oxygen minus 2. Okay, 4 oxygen minus 8 is equal to charge is minus 1. X minus 8 is equal to minus 1. X is equal to plus 7. Very easy. We have found out that manganese is present in plus 7. Manganese plus 7 becomes manganese plus 2. What is the change in the oxidation number? 7 to 2, 5. Okay. What is the number of electrons involved? Mn7 plus gains 5 electrons to become Mn2 plus. I think the answer is very clear. Change in the oxidation number is 5. Valency is 5. 7 to 2, 5. Number of electrons involved 5. So the answer is 5 Faraday. That is 5 into 96,500 coulombs. Upon multiplication you get this. Okay, so this problem is 3.12. Okay, next 3.13 textual questions. I hope you are enjoying. The question is, how much electricity in Faraday? They have specified, refer to the question, in Faraday to produce 20 gram calcium from calcium chloride, 40 gram aluminium from aluminium oxide. Man, this question I have seen several times in many of the previous year question papers. Exactly. Okay. So calcium chloride, Ca2 plus. What is the electron reaction? Ca2 plus 2 electron gives Ca. Calcium atomic mass 40. Aluminium atomic mass 27. Calcium 40, aluminium 27, magnesium 24, sodium 23. These are all familiar metals. Silver 108, copper 63.5, zinc 65.2. These things should be committed to your memory. Okay, don't refer to logbook and other books. Right. Now let us write the electrode reaction. Calcium 2 plus 2 electron gives calcium. This is the electrode reaction. According to the reaction, valency is how much? 2. 2 Faraday will deposit 1 mole of calcium. That is 1 mole of calcium is what? 40 gram. What is the question asked? How much quantity of electricity in Faraday to deposit 20 gram? Make it ulta. 40 gram of calcium, okay, is obtained from using 2 Faraday. Therefore, 20 gram of calcium. 40 ki 2 Faraday, not 20 ki 1 Faraday. Okay, next, come to this problem. Aluminium oxide. For aluminium oxide, what is the electron reaction? Al3 plus 3 electrons gives Al. 3 Faraday deposits 27 gram. We need to deposit 40 gram. What is the answer, ma? 27 gram of aluminum is deposited by 3 Faraday. Therefore, 40 gram of aluminum is deposited by how much? 40 gram into 3 Faraday divided by 27 gram. Gram gets cancelled. Upon simplification, you get 4.444 Faraday. Okay, this is the problem. Next, 3.14. Problem number 3.14. The question is, calculate, let us see the question. Amount of electricity required in coulombs for the oxidation of, very important one, 1 mole of water to oxygen. 1 mole of water to oxygen. Remember, they didn't ask like this. 1 mole of water to 1 mole of oxygen. No. 1 mole of water to oxygen. Here, the important conceptual understanding, comprehension lies on the LHS, not on RHS. Understand? Calculate the quantity of electricity in coulomb for the oxidation of 1 mole of water into oxygen. 1 mole of water into oxygen. For some of you, it may look boring. Or you may think otherwise, what happened to sir? He is repeating again and again or doing the same thing around. No. Extraordinary comprehension, ma. 1 mole of water to oxygen, not 1 mole of water to 1 mole of oxygen. Similarly, 1 mole of FeO to Fe2O3, not 1 mole of FeO to 1 mole of Fe2O3. So, remember, this is product, correct? We want to identify or we want to find out quantity of electricity required to convert 1 mole of water, 1 mole of FeO, correct? So, we need to ascertain the quantity of electricity only for reactant side, not on product side. Suppose if the question is, calculate the quantity of electricity required to obtain 1 mole of oxygen, required to obtain 1 mole of Fe2O3, then we focus our attention to product. Here the question is not product centric, the question is reactant centric. You should not be eccentric. Remember, this is very important. I want to do it again. The question is based on the reactant side, not on the product side. Correct? Right. 1 mole of water. That is why I am not pedaling O2. I am not stressing Fe2O3. The question is, calculate the amount of electricity in coulomb for the conversion of 1 mole of H2O to O2, 1 mole of FeO to Fe2O3. I hope this introduction might have been very clear to all of you. First, let me start from the easier one and go to the little bit challenging one. This is called ferrous oxide, this is called ferric oxide. FeO, ferrous oxide, contains Fe2 plus ion. This is ferric oxide, contains Fe3 plus ion. How will you know Fe3 plus? Because this 3 should come here, 2 should go there. Cross multiply. So, in this reaction, what exact change is taking place? What exact oxidation taking place now? Ferrous becomes ferric. Fe2 plus becomes Fe3 plus. Fe2 plus becomes Fe3 plus by losing 1 electron. So, in the overall process, what is the number of electron transferred? 1. What is the change in oxidation state? 3 to 2, 1. So, the answer is 1 Faraday. But we are not supposed to express in Faraday because the question they have clearly stated express in Coulomb. So, the answer is 96,500 Coulomb. Correct? Okay? Right. Next, come to this side. I hope you might have watched this. I am deleting this now. 1 mole of H2O. Actually, electrolysis. H2O splits up as 2H plus 2H plus O2 minus. Correct? Number of electrons transferring from anode to cathode will be same. Correct? There won't be any change. If you do the problem with respect to O2 minus, if you do the problem with respect to H plus, the answer is same. I would like to do with O2 minus. Why I am taking O2 minus now? O2 minus releases 2 electrons to become half O2. Hint, O2 minus 2 electrons are lost. You get O. What is O? O means half O2. That is the one thing I have written here. You can ask, sir, should I not do with the 2H plus? This is you have to argue. Definitely in offline mode, we would I am doing the same way. I am not comparing, but personally we can raise questions. Correct? So self question, self answer. I am asking myself, why I am not preferring H plus? I don't say that I am not preferring. I did H plus at the bottom, but we prefer O2 minus because O2 minus loses electron. The question is 1 mole of H2O to O2 involved in the oxidation, a loss of electron oxidation. Correct? That is why I am preferring. So how many electrons are involved? 2. So 2 Faraday. So 2 into 96,500 coulomb. Correct? I hope you understand. So the quantity of electricity required to convert 1 mole of H2O to O2 is 2 Faraday. Correct? The 2 Faraday with respect to O2 minus should be same as with respect to H plus. Correct? Many of you may be curious. That is why I am telling. These electrons will be released at anode. They will go to cathode. Cathode, what will be waiting? H plus will be waiting. 1 H plus 1 electron H. Totally 2 H plus. Another H plus another electron H. H plus H what? H2. Here 2 electrons are lost, here 2 electrons are gained. So there also 2 Faraday, here also 2 Faraday. So answer is same. Okay. For entrance goers, we worked out for 1 mole. By chance, if the question is, calculate the electricity in Faraday or calculate the electricity in Coulomb for the oxidation of 2 mole of water. You need not work out. Immediately you say, sir, for 1 mole of water, 2 Faraday. 2 mole of water, 4 Faraday. How many coulombs? Here 2 into 96,500 coulomb. There 4. Okay, 4 into 96,500 coulomb. Correct? So that is the answer. So problem number 3.16. By doing problem 3.16, I am informing you that problems based on Faraday's first laws in textbook exercise, I am telling you, will get over. All problems I have solved. No assignment for you. In the next videos, coming video, we will be doing again with the Faraday's first law with the extra problems. Okay. As I informed you earlier, we will do problems till I get personal satisfaction. Till then, I will be doing problem. So solving more problems will relieve you of academic problem. Okay, right. Actually, I tell you the synopsis of this problem 3.16. In 3 cells, cell A, cell B and cell C, zinc sulfate solution, silver nitrate solution, copper sulfate solution. 3 solutions are connected in series. These three solutions, 1.5 ampere current is uniformly passed. So cell A consists of zinc sulfate, cell B consists of silver nitrate, cell C consists of copper sulfate. Through all the electrolytic solution, uniform current of 1.5 ampere is passed. Okay. Upon passing 1.5 ampere, in cell B, 1.45 gram of silver is deposited. Cell B. Using that, you have been asked 3 questions. First question, how long did the current flow? How long did the current flow? Second one, what is the mass of zinc deposited and what is the mass of copper deposited? Okay. Coming back to the first question, how long did the current flow? Q is equal to I into T. So T is equal to what? Q by I. This is the formula. How long means time. In order to find out time, you need current ampere, that is given. But quantity of electricity Q is not given. They are not given quantity of electricity. Then we have to find out quantity of electricity. So indirectly, in order to find out quantity of electricity, you are given mass of silver. Correct? 1.45 gram. I really like this problem for one reason. The reason is this problem tests your ability to convert mass into coulomb. Mass into coulomb. In previous problems, coulomb into mass. In this problem, mass into coulomb. In 11th CBSE, we have studied mass into mole, molar mass to mole into mass, like that. That combination, molar volume to number of moles. Okay, very easy. So, using this, using mass, I need to obtain quantity of electricity. Okay, for that only I have written these three equations. Today, we began with, in this video, we began with the electrode equations. I hope the first problem, nickel nitrate. I am going to sign off with the electrode reactions. Correct? As the beginning, so the ending. Okay, right. In zinc sulfate, ZnSO4. What is electrode reaction? Zn2 plus 2 electron gives Zn. Column 1. Column 2, silver nitrate. Ag plus electron gives Ag. Third column, copper sulfate. Cu2 plus 2 electron gives Cu. We don't have to come to column 3 and column 1. First, we do with the middle column. Okay, what is middle column now? 1 Faraday of electricity deposits 108 gram of silver. That is 9600 coulomb deposits 108 gram of silver. How you ought to interpret now? 108 gram of silver is deposited by 9600 coulomb. Therefore, 1.45 gram of silver is deposited by how much coulomb? What is the answer? 1.45 to 96,500 divided by 108. Correct? So, 1295.6 coulomb of electricity. Remember, this amount of electricity is passing through zinc sulfate, passing through copper sulfate. You can ask me, how sir the same quantity of electricity? Because the same ampere current, same current, same quantity of electricity. Okay, so first let us evaluate the first one. What is the first one? Time is equal to Q by I. So, Q, quantity of electricity, 1295.6 coulomb divided by ampere, 1.5 ampere. You know very well that coulomb divided by ampere is seconds. 863.73 seconds. You can stop here itself, or if you want to convert into hours, divide 863.73 divided by 3600, because you know 1 hour is equal to 3600 seconds. Okay, right. This is first half. What is the second half? How much amount of zinc deposited? How much amount of copper deposited? Come here. Zn2 plus 2 electron gives zinc. Had it been in offline class, immediately some of you might have asked me, sir, zinc should we memorize, copper should we memorize the molar mass? Immediately I would have said in affirmative mode, yes. Zinc 65.3, copper 63.5. Correct? So valency is 2. 2 Faraday deposits 65.3, or 2 into 9600 coulomb deposits 65.3. In this solution, what is the quantity of electricity passed? 1295.6. Therefore, 1295.6 coulomb deposits how much? So 1295.6 into 65.3 divided by 2 into 96,500. The answer is 0.4383 gram of zinc. Come back here, copper 2 plus. 2 Faraday deposits 63.5. 2 into 96,500 coulomb deposits 63.5. 1295.6 coulomb will deposit how much? This answer. When you solve zinc and copper, the amount deposited will be almost same, because here it is 65.3, here it is 63.5. hardly 1 point something is the difference. So final answer 0.4383, here 0.4262. So these are all the things you must take into account while solving the problem. Some of you upon solving very eagerly and sincerely will be referring textbook back answers, correct? Don't have that attitude. Have a kind of comparison. Whether this answer and that answer they coincide or they are almost matchable now. Yes. Your answer should match, not patch. Okay. So 0.4383, 0.4262. Okay. So all exercise problems got over. After watching this video, do work out all the problems. I trust all of you will work out the problems. Those who are having some refresher books, you can go some extra miles. Okay, Mama? So with happiness and cheerfulness, and I am taking leave of you. In the next video, we'll meet you again. Thank you.